Hello, Agent here, coming to you from the nice and cool sub-underground bunker. Scientology is pretty much a dead meme, so I decided to make a series of videos on a project I got involved in. It's a large radio-controlled vehicle. It's a three-wheeled vehicle that has a quarter horsepower steering servo and some very large traction motors. This project involves a very large radio-controlled vehicle. It's 8 feet long and weighs several hundred pounds, so we can't really use off-the-shelf radio control servos and electronics, so we're going to have to use some industrial stuff and build some custom electronics for it. For the traction motors, we're using a Curtis 1203, good for 40 amps, 24 volts. That'll make it run forward and backwards. To do the steering, I designed the steering servo. Just got all the schematics written up. This thing's going to have special effects, lights and sound, and it's quite a deal. So and the client has a budget, so we're putting everything in these NEMA watertight boxes. Now here's a short demo of the prototype circuitry for the steering servo. Okay, this is a test of a steering servo. It's running on electronics, is running on 12 volts. The motor is running on 24 volts. Steered by wire. Here's what I'm doing. Rotating this pot. Looks like the initial prototype's going to work. You get more than 180 degree steering range. No backlash, no hunting. There's the H bridge. 6 transistors on a heatsink. Diodes and resistors. Here's the comparator. It's a window comparator made out of a LM339. And as we turn this pot, the steering nose wheel turns appropriately. On 24 volts. We're going to run the motor on 36 volts now. This is a lot snappier. This is almost in real time. As you turn the pot, it moves instantly. Uh, 24 would be sufficient for this application. We're on 24 volts now. .24 volts into a 12 volt gear motor. And it works. I've designed the steering servo electronics and drawn up all the schematics, and now what I have to do is turn these schematics into a circuit board that'll fit in this box. So after I fine-tune the schematic and finalize all the circuitry, I have to do a circuit board layout. I use Adobe Photoshop, and I print out a couple of test copies, make sure it's right, and then finally I end up with a laser printed transparency that serves as the etch mask for printing the board. And I have to build 6 circuit boards for this project. Design the circuitry and lay it out. It's all converting the pulse width signal from the Futaba receiver to DC voltage control, 0 to 10 volt control voltage, since this is all completely different than standard servo circuitry. And here's a short tour of the bunker. I make my way from the computer back through the mess here. Some of the pending projects. I mainly work on audio, video equipment. There's a bunch of stuff here to do. But I like these big projects, because I'd much rather do design work than repairs. And here's the junkyard. It's going to be a long-term project, probably take all summer. Like I said, I have a budget, so we're doing some really neat stuff, and I'm going to put up several parts of the video as the project progresses, so watch out for the next video. Thanks.